We are going to start off today with doing some similar figures. So find the value of x in each pair of similar figures, and I told you to round it to the nearest tenth in case they don't come out to be pretty numbers. A lot of times if they don't come out to be pretty numbers, they'll probably tell you to round it to something. But anyway, these two are similar figures, and you can tell that the 12, the long version, goes with the long bottom down here, and this kind of slanted going up goes with the slanted going up over here. And of course they're parallel, so if this is 3, this one's 3. So the x and the 3 are corresponding sides, and the 12 and the 5 are corresponding sides. So one way to do it is to find the scale factor. 5 times what will equal 12? Or 12 divided by what will equal 5? So if 5 times some number equals 12, I can take 12 divided by 5 to find out what that number was. So if you go put that in the calculator and do 12 divided by 5, it winds up being 2.4. So the scale factor is 2.4. This figure is 2.4 times bigger than this one. If I do 5 times 2.4, I get 12. So to find the missing side over here, I can just simply go 3 times 2.4 and see what the bigger number is. So that's the easiest way to do this one. You could have also set up a proportion. You could have said x over 12 is equal to 3 over 5, and then done the butterfly method and cross-multiplied and found the missing x. So perfectly good way, either way to do that. And then 3 times x, if you do that math, you wind up getting, let's see, I'll put it up here, x is equal to 3 times 2.4, just so you can see it. And that winds up equaling 7.2, and this was inches. So 7.2 inches was the answer on that one. Okay, that's not a very pretty 7 in there, but it's a 7. There we go. So this one, now you got to kind of be a little bit careful with the way they drew this one. Here's the little vertical part, right? And here's the little vertical part. But they didn't kind of orient in the same way. So notice that this is kind of a bigger angle, and this is a smaller angle up here. There's the smaller angle up there. So this top piece goes to the top piece over here. The sharp angle down to the point, the sharp angle down to the point. It's not the big open angle down here, right? So the 18 corresponds with the x, and the 4 corresponds with the x minus 12. So since these are not, I don't have corresponding signs with numbers on both of them, I can't go find the scale factor. So instead, this time you have to set up a proportion. And you could set up, when you set up your fractions, this thing equals, fraction equals a fraction. So you could, for the first fraction, you could go 4 over 18, and then put x minus 12 over x. Or you could do 4 over the x minus 12 is equal to the 18 over the x. You could have done 18 over 4 is equal to the x over that piece. So as long as you're consistent with which pieces you put where. I usually like to, sometimes just like to do the same figure in one fraction. So I've got the little short piece over the long piece. So this is 4 over 18. You also want to double check that the units are all the same. Excuse me. Excuse me. Don't know what grabbed my throat there, but something did. Okay, so 4 over 18 is equal to, so short piece over the long piece, so this is going to be short piece. Remember, we always put parentheses around the polynomials, so this is short piece x minus 12 with parentheses around it, all over the x. Okay, and then cross multiply. This times this, and I put parentheses around that, so I'll remember to distribute, is equal to 4 times this. So when you set this up, you got 4x, that times that is 4x, and then this times this. 18 times x is 18x. And if you do 4 times 12, you get negative 216. There you go. So all I did was distribute 18 times the x and 18 times the negative 12. So there's that side over there. And then to get x on one side by itself, you could go either way you want to. I'm just going to move the negative 4x to the left, so minus 4x. So that gives me 0 is equal to 14x minus 216. And then, of course, add 216 to both sides to get the 216 to the other side. Oops, 216. So this is 216 is equal to 14x. And then to get x by itself, you divide by 14, divide by 14, and x winds up being equal to 15.3. And this was meters. Okay, so that's what my missing side was, 15.3 meters. All right, so here's another one where they give you a little verbiage behind it. But anyway, her height and her shadow is proportional to this height and its shadow. So again, when you make this proportion, because I can't do it with just a scale factor because I've got an x minus 2 in this thing, and I can't see what the scale factor is to get from that to that. Or you actually could see this. Well, no, you don't have the scale factor for sure, because I need the scale factor from here to here or from there to there, and I can't tell the scale factor with the x's in there. So you have to set up a proportion. So I'm going to set my proportion up over here. So I'm going to do fraction equals to a fraction. And again, I could do this over this is equal to the vertical over the horizontal, or horizontal over the vertical is equal to the horizontal over the vertical. A couple of ways to do it. You could even do this over this is equal to that over that. I'm just going to do 5 over 4. So 5 over 4. Another thing I was trying to say, saying go make sure all the units are the same. These are all feet, 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 feet. So as long as they're all feet, you don't have to worry about converting one of these so they all match. So 5 over 4 is equal to x over x minus 2. X over x minus 2. Remember, if there's a polynomial, more than one piece, put parentheses around it. So then when you do your multiplication, you remember to distribute. So this is 4x is equal to, and when I loop these up, remember this 5 is going to get distributed. So this is 5 times the parentheses. So 5 times x is 5x, and 5 times the negative 2 is negative 10. Now, let's get the thing, x is on one side. So you could do the 4x to this side and the 10 to that side. I tend to like taking the small to the big. So minus 4x, which means I have 0 left over here, and there's a 1x minus 10. Add 10 to both sides, and of course 10 is equal to x. So 10 feet was my missing height. The height of the slide was x equals 10 feet. All right. Okay, this one down here, again, they give you a small desk and a bigger desk, and they say they're proportional. So you do have numbers in these, so if you wanted to, you could do the scale factor. To get from 24 to 36, we could figure out what we're multiplying by. So you could take the 36 divided by the 24 to see what the number is you're multiplying. And 36 divided by 24 is 1.5. So 1.5 is my scale factor. Meaning, if I take the side over here and multiply it times 1.5, it equals, so 24 times 1.5 equals the 36. Whatever x is times 1.5 would equal to 54. But since I'm going to go from big to small to find the missing one, I need to divide by 1.5. So 54 divided by 1.5 will give me what my x is. And if you go and do that math, it winds up being 12. Is it 12 on this one? I'm looking. What was, oh, no, this one's not. This one's 36 inches. So this one, x winds up being 36 inches. Which is kind of funny because this was 36 inches over here, but it just happened to work that was also 36 inches across the length there. Okay, these two down here. So again, we got scale factors, and we're looking for the missing side, and here's my missing side. So make sure they're oriented the same way. This one goes with this one, and that one goes with this one. So since they're both numbers, you could find the scale factor. 14 times something, some scale factor equals 29.4. So if I take 29.4 divided by 14, I can see if it's a nice, pretty easy scale factor. And this one, the scale factor winds up being 2.1, which is not bad. So I can take this times 2.1 and get that. Whatever this number was times 2.1 would be this. This figure is 2.1 times bigger than the small one. But to go from the small one, or the big one, back to the small one, I need to divide by the scale factor. So 25.2 divided by 2.1 will take me back to this one. And if you do that math, 25.2 divided by 2.1, you wind up getting 12 meters for x on that one. So scale factor is a perfectly good way to go. You can also set up a proportion. You could have said this over this is equal to that over that. A lot of ways to set up the proportions and then cross multiply and find your x that way. Now be careful on this one, because are these oriented the same way? No, this is the tall side on the right, but this one has the tall side on the left. So these two sides correspond together. You'd actually have to take this one and flip it over for it to be oriented the same way. But this side goes with this side, and then the shorter side goes with the shorter side. Do I have numbers on both these short sides? Yes. So could I find the scale factor? Yes. 3.6 times some number will give me 7.2. And then all the sides over here times that same scale factor will give you their corresponding sides on the big one. So to find this missing scale factor, I could do 7.2 divided by 3.6 and see what it is I'm multiplying by. So if you do 7.2 divided by 3.6, you get a scale factor of 2. Oh, this was an easy one. Scale factor. The scale factor was literally 2, meaning this one is 2 times bigger than this one. 3.6 times 2 is 7.2. 5.1 times 2 is whatever this thing is. So 5.1 times 2, and I do believe that's 10.2. So x winds up being 10.2 millimeters. There you go. And you could have set up a proportion. Again, you could have said this over this is equal to that over that. Short over long is equal to short over long, or any other version of that that you wanted to set up. Okay, so that was it for this. Now, the other side, we're doing a bunch of fractions. I'm debating whether to stop the video or go on and continue on. I think I'm just going to continue on, just make this one long video. Okay, so an example on this, when we're doing these, we're going to solve these fractions. Now, one way to solve fraction, or equations that have fractions in them, you could, get common denominators and do all the messy fractions and stuff, but there's a simpler way to do it when you've got a bunch of fractions mixed in an equation. You can simply multiply the whole equation, in other words, multiply both sides of the equation by the same number. That will clear out your fractions. So you need to think about what is the common denominator that you would use. And of course, 2 and 4 both go into 4. So 4 would be your common denominator if you wanted to change them all into fractions with 4s on bottom. However, an easier way to do it is to multiply both sides by that common denominator. So if I multiply the right side of the equation by 4, I have to multiply the whole left-hand side of the equation by 4. So that means it's going to be 4 times the first fraction and 4 times the second fraction and 4 times the number on this side. Now, when you multiply 4 times this one, there's just a little piece here, so that means 4 times 1 on top and 2 is on bottom. Can a 2 on bottom cancel out with the 2 that's inside the 4? Yes, which means once that 2 cancels out with the 2 inside the 4, I just have a 2 left over, and 2 times 1 is 2, and the fraction cancels out. Or if you want to think about it this way, 4 times 1 is 4, and 4 divided by 2 is 2. The fraction went away. And then 4 times 4x. Well, if I multiply 4 times this, I'm just going to pretend like I did it, so I'm going to bring it in here. So now here's the 4 inside where you can see it. Well, the 4 and the 4 cancel out, and I'm left with x. That's why we're doing this. So if you had multiplied this one, you would have 4 times 1, and of course, I can divide by 2 and divide by 2, and that goes away, and this becomes a 2, which is what we did. 2 times 1 is 2. And then 4 times 5 on this side is 20. The beauty of that is, once you multiply this messy step of multiplying everything, all the fractions are gone. Then you just minus 2 on both sides, and x equals 18, right? Okay, so clearing fractions is a good way to do them when you have a lot of fractions kind of mixed all through the equation. So that's the example I'm going to do. So number 1. With that being said, if, though, you have an equation that is a fraction equal to what could be a fraction, can I make a whole number into a fraction? Yes. Is this simply a proportion? Yes, it is. So if you have just a single fraction equals a single fraction, do a proportion. It's just the easiest way to go. Do your butterfly. 10 times 50 is equal to 1 times x. That means on this one, x is already by itself. So x equals whatever 10 times 50 is, which is 500. So x equals 500 on that one. That was nice and easy. Okay. Number 3, is this a fraction equal to what could be a fraction? Because I can make a whole number into a fraction. So if this is a fraction equal to a fraction, we're going to make it into a proportion. We're just going to cross multiply this thing. And I've got this one set up here where we can do this one, where we have some more room. So I made that whole number into a fraction. And now, remember, whenever we're doing these binomials and trinomials and things, put parentheses around them if you're going to be doing math with them. So that means I'm going to distribute. When I multiply 4 times this thing, the 4 gets distributed to both pieces, right? And then 6 times 1. So if you want to write it down where you can see it all, 6 times 1 is 6 is equal to 4 times x minus 1. So that way you can see that we're going to distribute this side. 4 times x is 4x. 4 times negative 1 is negative 4. Now you could have done it up here and said 4 times x is 4x and 4 times negative 1 is negative 4. I just want you to see what we were doing. So now that you've got the the cross multiplying thing out of the way, we're just solving for x. So add 4 to both sides. Of course, that's 10 equals 4x. Divide by 4, divide by 4. And x winds up being, because the 4's cancel out, 10 divided by 4, where's my number that I did this one? This is number 3, right? Yeah, number 3. X winds up being 2.5. There you go. So all I did was this 10 divided by 4 was 2.5. Number 4. So number 4, I've got it copied up here, is again a fraction equal to a fraction. So again, just cross multiply. That's the easiest method to do when you have a fraction equal to a fraction. So 4 times 25 is 100, is equal to x times x, which is x squared. Now, if you remember when we were doing our radicals and stuff, squaring and square roots undo each other. So I need to get x by itself. So how do I undo squaring? You're going to do this a lot next year. You're going to take the square root. If I take the square root of one side, I must take the square root of the other side. So the squaring and the square root undo each other, so I'm left with x, which is why we did it. That just undoes the squaring. Now, square root of 100. what number times itself equals 100? And of course, you're going to tell me that's 10. But remember, if we're solving and we put the square root around it, that means I want the plus and minus answer, because x could have been a positive 10. 10 times 10 is 100, or x could have been a negative 10. Negative 10 times negative 10 is also 100. So x is plus or minus 10. Both numbers will work. All right, so that was number 3. Or no, that was 4. Number 5 down here. All right, now this one, when you look at number 5, do you have a fraction equal to a fraction? No. Had it not had this front part, we could have made it into a fraction equals a fraction. But I've got an extra piece of addition on here with another fraction over here. So I have 2 fractions on this side, if you want to think about this as being a fraction. But I've got 2 pieces over here, not just a single fraction equals a single fraction. So I can't do my cross multiplying thing. So this is what I'm going to do by that example that we showed at the beginning when I said let's get rid of the denominators by multiplying both sides by something. So notice, now we could, if we wanted to, the x's are the same on the denominator, so we could subtract 5 over x on both sides and do all that math, and it's long and complicated and a lot of involved steps in that. We could do it that way. Again, the easier way is to get rid of the fractions in the first place. So x, both of these will go into x, so I can just simply multiply by x. I'm going to multiply the right side of the equation by x. I'm going to multiply the left side of the equation by x. And remember, I put parentheses around it because I'm going to distribute x times the first one and x times the second one. So if I do x times this fraction, is there an x on top and an x on bottom? Yes, so they're going to cancel out, and I'm going to be left with just the 11. X times 2 is going to be a positive 2x. And then on this side, x times this thing. So I'm multiplying x's. I've got an x on top and an x on bottom. Are they going to cancel out? Yes, which is why we're going to do this, and I'm left with a 5. So multiplying by x on both sides, what it did was it gave me this problem with the x's gone from the bottom. So now just solving for x, subtract 11 on both sides. 2x equals, that's not a pretty 11, negative 6 divided by 2, divided by 2, x equals negative 3. And voila, there's the answer without having to do all those fancy fractions and stuff. So the only tricky part is multiplying both sides by that number and being careful that you cancel things out and do the multiplication right. So that's the tricky part on that. And we'll practice these a little bit this year just so you get your feet wet. You're not going to be experts by any means at it this year. We're just getting you exposed to it. All right, number 6 up here. So 6 is, again, a fraction equal a fraction, but it's got an extra piece over here. So I can't treat it like a proportion, right? Because I've got this extra piece over here. So the easiest thing to do on this is to literally clear the bottom denominators out of here. So I'm going to multiply both sides of the equation by some number that they will both go into. And if you multiply 3 and 2 together, they both go into 6. So this side of the equation is going to get multiplied by 6, and this side of the equation is going to get multiplied by 6. Okay? Now, 6 times x means I have 6x on top and 3 on bottom. What's 6 divided by 3? It's a 2. And if you want to think about it, the 3 down here cancels out with the 3 that's inside the 6, because this is 2 times 3. I'm going to rewrite the 6 as 2 times 3. So, I hope that sharpens up. There we go. So if I rewrite 6 as 2 times 3 and ignore the 6, right, that's still 6 times this side. There it goes. Now it's focused again. The 3 cancels out with the 3, and you're left with the 2. So 2 times x is 2x, but the 3's canceled out. And on this side, if you want to think about this 6 as being 2 times 3, when I multiply 2 times 3 times this one, does the 2 and the 2 cancel out? So I'm left with 3 times x, which is 3x. And then I may as well just do the whole number 6 on this one. So 6 times 7 is negative 42. So all we were doing is multiplying 6 times this, 6 times that, 6 times this. But that way you can see that the 2's and the 3's were canceling out when you did that. So now, look, no more fractions, which is the beauty of that. Get x's all on one side, so I'm going to subtract 3x on both sides. I know normally I go the other direction, but I thought, what the heck. Minus 1x is equal to negative 42. We're going to divide by negative 1 to make it positive. And that means x is equal to a positive 42. Voila, there we go on that one. So that was, what, number 6? Yeah, that was number 6. Okay, number 9. Ooh, looky, is this a fraction equal to a fraction? Yes, so we can do this one with the cross-multiplying technique. I don't have to clear fractions, so I don't have to do that stuff. But remember, when we do this math, if you put parentheses around it, you'll remember to distribute. So 2 times this is equal to 7 times that. Okay, so if you want to do the distribution all in one step, 2 times 4x is 8x, and 2 times negative 3 is negative 6. And that is equal to, because this times this is equal to that times that. 7 times the x, 7 times the 5, because remember, we're distributing into this parentheses that's over here. So now, parentheses are all this stuff is gone, we're just solving for x. So let's subtract 7x on both sides. That gives me 1x minus 6 is equal to 35. Add 6 to both sides, and x is equal to 35 plus 6 is that 41? That's 41. Is that what I got before? I can't remember now. What number was this? This was number 9. Where did I do number 9? Oh, I did it on the back over here. I'm going to check it real quick. Yeah, number 9 was 41. Sometimes I just like to double check myself, make sure I didn't make a little mental oops in place. Okay, so number 10. Again, I can't make this into a fraction equal a fraction, even though I would like to and do cross multiplying because I have this extra piece over here. But the good news is, look at the denominators. Are they both the same? Yes. So if they have the same denominators, can I just do 10 minus 6 on top? Yes. So this is actually 4 over x minus 3 because the bottoms stay the same, right, when you're adding and subtracting, equals 8 over 1. So now is this a fraction equal to a fraction? Can I cross multiply? Yes. Put your parentheses around this so when you do this multiplication, you don't forget to distribute. And 4 times 1. So 4 times 1 is 4. I'm going to move this one over here. So 4 times 1 is 4, and 8 times this parentheses. 8 times x, 8x. 8 times negative 3 is negative 24. Solving now for x, I can add 24 to both sides, so plus 24. So this winds up being 28 is equal to 8x. Divided by 8, divided by 8. So they don't always come out to pretty numbers. So 28 divided by 8, let's see what number was this. This was number 10. Where did I do number 10? 28 divided by 8 wound up being, 3.5. Not such a bad number after all. So 3.5. So there's my x on that one. That was number 10. Okay, let's see what else we're going to do. We're going to do number 12 and number 15. I think that's the only ones we had, right? I don't think I had anything else on here. Did I skip any? 3, 4. I'm looking to see if I did them all. 1, 3, 4, 5, 6, 9, 10. Oh, we skipped 7. I need to go back and look at 7. And 12. We're going to skip. Which one did I have crossed off? I crossed off 15. We're going to skip 15. So we're skipping 15 altogether. There's no reason to do extra ones of those. We're just getting our feet wet this time. So if we're looking at number 12, you want to make it into a fraction equal a fraction over 1, right? But I have 2 extra fractions over here. But the good news is, hey, do these have the same common denominator? So can I just add the top pieces together? Yes. And remember, when you're adding, well, not such a big adding, but if this had been a subtraction problem, I would have to distribute a negative 1 to both things in here. But since it's positive, positive 1's not going to change it. X is still x, and 2 is still positive 2. So this winds up being 7x minus 2 plus x plus 2 all over x, right? The denominator stays the same. You just add all the top part equals x. Okay, so now, if we go and combine all these like terms, 7x and x is 8x. So now I have 8x. Oh, look, the 2 and the minus 2 cancel out. So we're left with 8x over x is equal to x. Oh, but look at this. Do I have an x over x? Are they going to cancel out? They are factors. So 8 equals x. So literally 8 is just x equals 8. There's the answer right there. No more math involved on that one. Sometimes you get lucky and they're really easy to solve. Going back to number 7 real quick. Let me find number 7 on here. There it is. Okay. So on this one I skipped over. Again, I can't just do fraction equals a fraction and cross multiply because I have this extra fraction over here. So instead, we want to clear these fractions. And so 3 times x would be a good denominator that I would use to clear everything. So I'm going to multiply this side by 3x, and I'm going to multiply this whole side by 3x, okay? So when I multiply this first fraction by 3x, the 3's are going to cancel, and this is x times 1, so that's just x because the 3's are now gone. The bottom number's gone. 3x times this one, I'm going to put and this is going to be a minus. So here's my 3x that I'm multiplying by, right? So see how the x is on top and x is on bottom? They're going to cancel out. So this is just 3 times 4, which is 12, is equal to. Are the x's and x's going to cancel out because they're being multiplied? Yes, and 3 times 1 on top is the 3. So now you're left with x minus 12 equals 3. Just add 12 to both sides. And of course, that means x is equal to 15. And I think that was number 7, right? Yep, that's it. Okay, this is in a nutshell. Don't worry about if you don't get some of this stuff this time, because again, we're just introducing you to all this big crazy fraction stuff that you'll get a lot more of in Algebra 2 and a little bit in geometry. See y'all next day.